Hi guys. So I've been hearing some questions in my face-to-face class, and a couple emails have come through about um, the class relationships, the classes that you're creating for the Module 2 project. And this is a common discussion point, so I felt it was a good opportunity to make a video and talk about what's going on here with some of these relationships. What is a DAO and what is a factory, and do basically a quick sample demonstration of how you would apply these patterns. And so I guess the best topic to start off with is why do we do things like use the DAO design pattern? Hopefully you've done the reading on that. When we're talking about design patterns, basically all a design pattern is something that developers have kind of figured out over the course of the past few decades is just a general good idea. When you follow design patterns, you teach yourself about design patterns and apply them to software, you're generally going to get better results than when you don't, especially when you're working in a team. It allows you and your teammates to have kind of a common language, common understanding of how your classes are going to be organized, naming conventions, expected behaviors, and things like that. We've actually got two design patterns that are being demonstrated here. One is the DAO design pattern, which there's a writing about in D2L, a brief snippet that talks about what are these DAO CRUD behaviors, create, read, update, delete. There's actually another pattern going on here known as the factory pattern, which you may be familiar with from the introductory Java course because the Muroc textbook uses the factory pattern in at least one of the projects. But we're going to talk about that as well, and I'll show just a brief demonstration of why we do the factory pattern. But starting out with the DAO pattern, and I feel like this is an important point to get across because we're going to see transition here going into Module 2. Basically, what the DAO pattern tries to accomplish is to separate the core functionality of your program from the functionality that has to deal with storing data. And storing data could mean interacting with a database or reading or writing to and from files, as is the case with the Module 2 project. It could mean accessing data over a network connection off of a website or something like that. So a DAO, a data access object, could fill any of those roles. But the general idea is that we want to separate our concerns. We don't want the core logic of our program, which is contained inside of our main app class, to be concerned with, for example, file input output. We want to have specialized components, and the DAO is just an example of a specialized component that deals specifically with reading and writing data. Typically, you'll see one DAO class for each type of data. So in this case, we're dealing with the contact type. So the contact type has its own DAO class. You'll also see a DAO class for each type of data for each method of storage. So what I mean by that is right now we have a file contact DAO, but in Module 3, when we transition all of our contact data into a database or relational database system, we're also going to have a database contact DAO. And so we'll be able to choose the DAO that's appropriate for the type of data that we want to access. In order to make sure that we have consistent behaviors between all of our DAOs, so we have our file contact DAO, we want to make sure that it has the same behaviors as the database contact DAO that we designed in Module 3. We're going to develop an interface that kind of sits in between. It defines all of the required methods for a contact DAO. And so therefore, when we want to make the change farther on down the line, all we have to do is choose a different implementation class. And then the code in the main method, which references the contact DAO interface can remain unchanged. And I'll show you a demonstration of that, well, right now. So this is building on the project code that I showed you guys last week in another video, where we have basically a product inventory system. I'm actually going to make a code of this a copy of this existing code, and let's call it DAO demo. And I'll upload this for you guys to use as well. And I lost it. There we go, DAO demo. All right, so DAO demo is basically a boiled down version of what you guys did for your Module 2 milestones. I have some array of products, and I can list the contents of that array and add things to that array. Very simple, there's no removal, there's no editing or anything sophisticated like that. But in the interest of this exercise, what I would like to do is get rid of using array-based storage. I would like to eventually have all of my product data stored in a text file. But what I'm going to do, just for the time being, first of all, I'm going to create my DAO interface, which is always going to be very simple. It's going to be very straightforward to define these interfaces. So I'm just going to add to my package new Java interface, and we'll call it product DAO. And again, if you've done the reading about data access objects, you may know, more or less exactly what's going to go here. It's worth noting that, there's different ways to do a DAO. There's different names for the behaviors or different sets of behaviors. These are just the methods that I chose for this class in particular, but when you get out there into the world, you may discover that different companies use different libraries that do DAOs differently. One thing that I want to point out here that may be a point of confusion for those of you looking at this demonstration as a way to kind of kickstart your contact applications, your Module 2 projects. You'll note that for the return type for create and the parameter type for delete, I'm using string instead of integer. The reason being that the kind of key field, the equivalent of the ID field for your contact applications in my product application is the UPC, which is a string. So you guys have the ID field, which is int, and that's going to basically be a unique key identifier for all of your contact objects. Whereas for products, instead, we have the string or the UPC field, which is a string. So that's why there's a difference in type there. Now that I have this interface that outlines those behaviors, I can create a new class that is actually going to be, I'm going to call this mock product DAO. This is going to be our DAO implementation class. I'm calling it mock product DAO because it's not really going to actually do any data storage. I'm actually just going to end up using an array here to store the data for the time being, and in a later video I'll demonstrate using a file instead. The mock product DAO needs to implement product DAO. And as soon as we do that, we're going to get the red squiggly indicating that we need to actually have those interface methods present. Remember, when you implement an interface, all of the methods in that interface must be implemented. So I'll allow NetBeans to fill that in for me. it's going to fill in this exception generating code, which is basically just a helpful reminder to actually do something with these methods. Otherwise, they're just going to throw errors. So we can get rid of. Actually, we'll tackle these one at a time. I guess first things first, we need a place for our DAO to actually store data. And so if we were actually working with a file here, we would need to have a method to say open a file and read its contents and things like that. Instead, I'm just going to use an array behind the scenes as just a way to mock this up. And I'll just start it out at 0. So in the read all method, where I would normally have to open up a file, read its contents, parse those contents into an array, and then return that array, here I can just return inventory. Oh, I didn't do the read method correctly. I've got to go back and correct this. If you recall from the reading, the read method also needs to have the key value present. We need the UPC of the product that we want to actually obtain. Okay. All right, so we're going to use a for each loop to see if we can find a product in our inventory that matches the UPC provided. And so if we find a match, we're going to store it in this temporary variable, and then we're going to break out of the for loop. And then we'll just return whatever we found. If the loop doesn't find anything, this will just return null. So that's something that you need to be aware of. Okay, so go back to main app. And we can knock this out. We don't need an array here in our main method. And so I'm going to come out this code for now. All right. So instead of having the array located in our main method is not going to do any data storage. Our main method is basically going to lean on our DAO class for doing the data storage. So we need to actually create a DAO. Then we can replace, actually, I probably didn't want to replace that code entirely. Instead of replacing that loop, because that's our printing loop, product array PD, product down PD equals. Okay, so that'll create our DAO object. And then product array inventory equals. So instead of storing the array locally, we'll call the read all method. The read all method will return our current array of products, and then we're going to print it out. By default, that array is going to be empty, so we won't see anything here when we actually do the listing. Okay, empty, and add products isn't implemented yet, so that would probably be the next thing to do. So the create method here, also going to be fairly simple because we're expecting that the actual product data will be provided by the parameter to insert into the array. So really this is just going to be a matter of increasing the size of the array and adding the new product. We have some of that code over here that we can use from our main method that we've already figured out. And we need to implement the arrays method. All right, and the product that we're going to add is the parameter entity. So this will make a copy of our array, increasing its size, and then it will insert the entity product into the last position in the array, and then it's going to sort the array. And that's basically all create needs to do, except for the fact that it's required to return a string. The reason why it's required to return a string and why you typically see this with create operations in a DAO is some DAOs have specific requirements for generating ID parameters. So for example, with your contact applications, the ID parameter is a value that could be generated by the DAO itself by looking at the existing IDs. When we get to module 3, we're going to have our database contact DAO actually generate the ID field for our contact objects. And because the create method will actually be generating that field, it needs to return the value that it generated in case it needs to be used anywhere else in your code. So basically, that's a long way of saying that you need to return the UPC here, or in the case of your contact application, you need to return the contact ID that was just added. That's also helpful confirmation that that item was in fact added to the data storage, and so you can go look for that. All right, so if I come back over to main app here, I can yank out that. And we're going to need to access our DAO again. And then we can just do product DAO.createP. And so this will take the product object that we read in from our read new product method. It'll send it to the DAO to create inside of our array, and it will create it inside of our array. Okay. Again, no products by default. If I add something, good old banana, price for banana, UPC for banana. Okay, there's banana sitting in our array, which is basically all we've done here is relocate our array storage from our main method into the DAO. Let's add something else. 5. All right, now we've got apple and banana sorted, living inside the array inside of our DAO. So note that there hasn't really been any functional change in our code. Our main app no longer needs the arrays class. So basically the program functions exactly the same way. And so when I demonstrate this kind of thing, it typically begs the question, well, why? Why would you want to do that? Why would you want to create all these extra files, all these extra lines of code, just to add some more lines of code to our main method here? The kicker really comes in when you want to change part of the code that does a specific operation. So, for example, when we want to modify the code that's responsible for reading data, We know exactly where that's located. We know that that's part of the DAO's responsibility, part of its role in the program. So if we want to change the code for reading data, we need to read from a different file or a different data source. We just go into the DAO and make those modifications there. It's not all tangled into our main application code. And plus, as I already stated, if we wanted to change the DAO that we're using altogether, we would only need to come in here and actually change the implementation class. Because we're using an array, we can actually swap this out. And so I'll show a quick demonstration of that. I'll just make another class that also implements product DAO interface. So I'll just call it mock2 product DAO. We need those methods. All right, and I'm not going to bother filling any of these in because it's just for demonstration purposes. But let's say, this was the DAO class that was going to open a file or, access some other kind of data or treat the data in a different way, use some kind of different storage mechanism. Just return an empty array and return a new product and return an empty string. So here we basically have another product DAO implementation, but this implementation does literally nothing. And now we want to change our code to use the new implementation. I could just come in here and change these references. Oh, very expensive banana. Okay. So that didn't actually store any data because I changed it to the mock class that doesn't actually do anything with the data. There's no data storage going on there at all. So it did nothing. It didn't remember the banana, and it will never provide us any useful information. But in reality, you may have several useful implementations of the product DAO interface that you want to be able to switch between. So this is great, the ability to change the DAO that we're using on the fly and to maintain those DAOs separately from the rest of our code. To take things a step further in terms of maintainability and convenience, that's typically where we introduce the factory pattern. And the factory pattern essentially just involves having a class that does this. It matches up the thing that you want, which is a product DAO, with the class that actually implements that interface. And that's all really a factory does. It builds a particular object to meet a particular need. So let's create a DAO factory. And for right now, our DAO factory is just going to produce one thing. We're going to have one static method here. And that static method is going to produce product DAOs. And so we'll call it getProductDAO. And literally all it does is create this mock product DAO object and return it, which that's not doing anything new. It's in fact literally doing exactly what we are already doing over here, which is creating a new, in this case, a mock2 product DAO, and it's assigning it to a value. So what's the big idea? Let's plug this in. Our new method, our new factory method, which again, all this factory method does is create this new object and return it. Okay. And I'm going to plug that in both spots. Okay, so now I've switched it back to use mock product DAO instead of mock 2 product DAO. So this should work again. All right, list has nothing in it. Let's add banana, price for banana, UPC. All right, there's our banana. Okay, so let's get out of there. And now the convenient part, where the benefits the factory actually kicks in, is when we do want to make this change. Previously, we had to make this change in 2 spots if we wanted to change from using mock product DAO to mock 2 product DAO, if we wanted to switch implementation classes. Now we only have to switch implementation class in 1 place, which is inside the factory. Seems kind of silly now because we were only using it in 2 places before. But in much larger applications, it can be a nightmare to change implementation classes and to actually go in and modify that code in several different locations. So trust me when I say that for something like a DAO, you want a factory in place so that you can make that change in a single location. So now that I've switched to Mach 2 product DAO, we're back to it not remembering any data. Okay, and so nothing there. I guess if we want to actually make use of this, we'll have to implement a DAO that actually does something new, like for example, file product DAO. And that'll be the topic of my next video. So I will see you then.